Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at arithmetic sequences. So a sequence is just a list of numbers. This here is a sequence, this here is a sequence, and these three dots at the end means it keeps going forever in that pattern. So each of the individual numbers is called a term. So for this sequence here, 4 is term 1, term 2 equals 10, term 3 equals 16, and so on. So this sequence here in black is a special type of sequence called an arithmetic sequence. So arithmetic sequences are special sequences of this form: A plus D, next term A plus 2D, A plus 3D, and so on. What is this actually saying? It's saying that if you take any term and subtract the previous term, you always get the same answer. Here, Tn means the value of term n. So T1 is the value of term 1, T2 is the value of term 2, and so on. So basically this means that we are adding or subtracting the same amount each time. This amount by which we're adding or subtracting is called the common difference. This is an arithmetic sequence because there's a common difference. We are adding 6 each time, adding the same amount. It also would be arithmetic if we were subtracting the same amount each time. On the other hand, this sequence here is not arithmetic. The reason is we're not adding or subtracting the same each time. Now you can probably see the pattern. We're timesing by 4 each time. But we've added 9 to go from T1 to T2. We've added 36 to go from T2 to T3. So this rule here is broken. We're not adding the same amount each time, so it's not arithmetic. So you can see from the form of an arithmetic sequence that if you want to know the value of an individual term, it's just a plus n minus 1d. First term is a plus 0d, second term is a plus 1d, third term is a plus 2d, and so on. So the value of any term is a, the first term, plus n minus 1 times the common difference. Here, n is the value of the term in which you're interested. All right, let's look at an example. So let's calculate the 30th term of the sequence 98, 95, 92. So this here is an arithmetic sequence because we're adding or subtracting the same amount each time. The common difference here is -3. If you want to figure out the common difference, you just take any term and subtract the previous term. 92 minus 95, 95 minus 98, you get -3. So clearly, A is the first term is 98. So if I want to know the value of the 30th term, which is T30, it's just going to be A plus n minus 1. So if I want the 30th term, n is 30. So n minus 1 is 29 multiplied by the common difference, which is -3. And you can just put that in your calculator if you like, you get 11. So let's look at this one. Calculate A and D. If the 7th term of an AP, that means arithmetic progression or arithmetic sequence, is 22 and the 18th term is 66. So hopefully you're thinking straight away we need to find two quantities at once, so let's use simultaneous equations. The first equation comes from the 7th term, so if T7 equals 22, what that means is A, which we don't know, plus n minus 1, so n is 7 when we're talking about the 7th term, n minus 1 is 6. A plus n minus 1d gives you the value of the term. Similarly, for the second equation, we have the 18th term is equal to 66. So that means A plus n minus 1, which is 17 now, d equals 66. So we have simultaneous equations here, two equations, two unknowns, very easy to solve. We're going to simply subtract the top equation from the bottom. A minus A is 0. That's what I do this, why I subtract. I want to eliminate one of the variables. 17d minus 6d gives 11d, and 66 minus 22 is 44. So 11d is 44. That means D is equal to 4. Now to find what A is, we just substitute into either of the equations. I'll just choose the top one. We get A plus 24 equals 22. So a is equal to -2. So this is the sequence, -2 is the starting term, and it goes up by 4 each time, and so on like that. All right, just 2 more examples and then we're done. So this question asks which is the first term of the sequence 1, 7, 13 and so on to exceed 500. So whenever you're attempting a question involving the term of an arithmetic sequence, we use the formula Tn equals a plus n minus 1d. Now this equation has 4 unknowns: t, n, a, and d. So you have to figure out which of those 4 you're finding. Now here I know A, I can easily figure out D, and I know the value of the term is T. I want to find N here. I want to find the number of the term. I want to find, is it the second term, or the 300th term, or the 50th term, whatever. So what I'm going to do is take my formula, substitute T, A, and D, and solve for N. So the value of the term Tn is 500. A is equal to 1. Now D, you can see clearly, is equal to 6 because we're adding 6 each time. So I simply solve this equation. I get 499 equals 6 outside of n minus 1. So now we divide each side by 6. We don't get a whole number, but that's all right. I'll show you how to deal with that in a second. We get 83 and 1/6. And then that is equal to n minus 1, so we have to add 1 to both sides. We get n is 84 and 1/6, or 84.16 recurring. Now, n should be a whole number. So why didn't we get a whole number? Well, it turns out if you were to keep going with this sequence, none of the terms would actually equal 500. So what do we do in this case? Well, what this is saying here is that the 84th term is a little too small. It'll be just below 500. We always round up. So the first term that will be over 500 is 85. So it will be the 85th term. It'll be just a little more than 500. The 84th term will be a little less than 500. All right, let's try this one here. We're told x, 2x plus 2 and 4x minus 1 are 3 terms that form an AP. Remember, that's an arithmetic progression or arithmetic sequence. Let's calculate the value of x. So the definition of an arithmetic progression is that if you take any term, so I'll take the third term, and you subtract the previous term, you always get the same answer. You always get the common difference. So third term minus second term must be the same as second term minus first term. So if we expand the brackets and collect like terms, on the left-hand side we get 2x minus 3. On the right-hand side we get x plus 2. So to solve this, we subtract the pronumeral with the lowest coefficient. So I'm going to subtract x from both sides. I get x minus 3 is equal to 2, and that of course means x equals 5. So this is the arithmetic sequence, 5, 12, 19, and we're done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.